to learn.
Can we concentrate now?
Yes. Yeah, you can concentrate, sir.
Mnapiga kelele alafu mwishowe mnasema hatujasikia. Now, last time we were looking at data analysis, and we did look through how we can analyze data using the measures of central tendency. We did say that the easiest and simplest way is to compute the measures of central tendency. And how do we define these measures of central tendency? These are measures that describe a given set of observations. And there are three methods by which we can use to describe. One is by determining the mean. Two is by determining the mode. And then three is by determining the median. We said that the mean is the average value. The mean is the average value. And this gives us a description of the average of a given set of observations. We did see that we can find the mean of a given set of observations, whether it's grouped or ungrouped. We also say that the mode, that's the most occurring value in a given data set, and therefore this is the value that has the highest frequency. We did see that if it has only one value, that's model. If it has two, it's bimodal, and it has more than two, then that is referred to as multimodal distribution. How to find the median? And we did agree that for the median, this is a measure of position. And as a measure of position, it gives us the central value of an array. So this central value is what describes that value that takes the central position. So we did describe the median for a given set of data as to that item that takes the n+1/2 item. So if there are two central values, then we do get the average of those two values. For grouped data, we gave the formula of how to estimate that value. Now we looked at some examples. And those examples that we looked at, some did not. Some of you had asked questions that you had not understood what it was all about. So I want to use an example so that we are all at par. I want to use an example so that we clear any alternative conception that we may have had from our class last week. So we have this exercise I had given you. We have this exercise I had given you, which you are supposed to find or to group. We had the following: 168, 142, 171, 153, 155, 164, 148, 159, 161, 172, 149,
High school.
171,
Yeah.
168, 155, 173,
Yeah.
164,
Mm.
149, 161, 142, 148, 164, 159, 164, 173, 164, 152, 153, 164, 155, 148, 164. There were a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and then 32. We had given this as the centimeters of the height in terms of the centimeters of students. And you are to generate a class, a frequency distribution table with a class of 142 to 146. I had given you that as an exercise. I want to use that so that we clear the measures of central tendency using that example. So if you did it correctly, you must have gotten the following. So what we have is the classification, we have the class. Then what we have is then the number of students. So we are told that we start with 142 to 146. Looking through this set of data, then you realize that which is the least? The least is 142. And which one is the highest? The highest here is 173, if I'm not wrong. So we wish to have this interval so that we capture up to the highest. We have already 142 to 146, where 142 is the least. So looking at this, then you realize that the class size is 5. Because from 142 to 146, we said that the class boundaries, these are the limits. The boundaries must extend from 141.5 to 146.5. So if you get that difference, you get 5. So the class size is 5. So how do we generate the other interval? This is generated by adding the class size, if you recall the procedure that we looked at last time. So with that in mind, therefore, we can generate the following so that we capture up to 173. So we shall have 147 to 151. So we add 5, 5, 5, 5. So adding 5, we get 152 to 156. 157 to 161. 162 to 166. Then 167 to 171. 172 to 176. So this becomes our classes. And if you did count the frequencies, how many of these fall within the intervals? Then you should have gotten the following, that for the first interval, you had 2. For the second, 5. For the third interval, 6. For the fourth interval, 4. Then 7. Then 4. And finally, 4. Then you get that total. That should give us the total. This is 7, 13, 7 plus 10, 17, 24, 24 plus 8, 32. Please confirm that that is exactly what we did get through. So with this in mind, we want to see how do we estimate now the mean, how do we estimate the mode, and how do we estimate the median. Remember, for the mean, if we start with the mean, we say that this is the sum of all the observations by the frequencies divided by the total number of observations, where this is being grouped. So this is going to be our midpoint. How do we determine the midpoint? Look at this interval, 142 to 146. It has 5 intervals. So if we get the middle one, we have 142, 143, 144, 145, and 146. The middle one will be 144. How else do we obtain this? If we get the average of the class limits, the lower class limit and the upper class limit, 142 plus 146, that gives us 882 divided by 2, because we are averaging that. This gives us 144. So the easiest way is just to average the limits, the lower limits and the upper limits. So with our example, our classes are the frequencies. The frequencies are the number. So we get our midpoint, x. So for the first interval is 144. For the second interval, 147 plus 151 divided by 2, that should give you 149. If you worked out that well, then you will have 1, 4, 1,
159. 159.
1, 4, 169, then finally 174. Now we have our midpoints, we have our frequencies. For us to get the total sum of observations, then what we need to do, we need to get the product fx. We need to get the product fx. So we get the product 2 by 144. That gives us 288. 5 by 149. 5 by 149, that gives us 745. If you worked out correctly, then you will get the following values. Please confirm. 924, 636, 1148, 676, and finally 696. So if you get this total, then it should give you 5113. 5113. And therefore, substituting in our formula for the mean, this will give us 5113 divided by 32. So this will approximate to a value of 159.78. 159.78. Whose interpretation we gave last time? That this is the average value of whatever we are given, which is the height in centimeters of the student. So the average height of these students is 159.78 centimeters. That is the average, and that is the mean. We did also look at how we find. Please take notes and mark this. This is our mean. Our mean is 159. Then we looked at how we estimate the mode. For the mode, we did say that we estimate this as L plus F1 all over F1 plus F2, this multiplied by I, where L was the lower class boundary of the model class. F1, the difference between the frequency of the model class and the pre. F2, the difference in the frequency of the model class and the post. Then I is the class height. So what we need to do is to identify the model class. So what is a model class? A model class is that class that has the highest frequency. So we look through our table. We have the frequencies given. Which one is the highest? The highest here is 7. So 7 corresponds to the interval 162 to 166. And therefore, our model class is 162 to 166. 162 to 166. So from this, therefore, with a frequency of 7, we are able to now substitute. If we substituted, we shall have our mod as what is the lower class boundary? How do we determine the lower class boundary? Recall from what we did last week.
161.5.
162 to 167. Where do we get the boundary? We average these two. Between 161 and 162, that should give us 161.5. Then for the next 166, 167, this should be 166.5. And this should therefore extend to 166.5. And therefore, lower class boundary is 161.5, and the upper class boundary is 166.5. And hence, our L shall be 161.5 plus F1, the frequency of the median class, 7, and the premodel. So 7 minus 4, that gives you 3. Divided by F1 is 3 plus F2, the difference in the frequency of the model class and the post. The difference between the model class and the post. So that is also 4, so it gives us 3. And this we multiply by the class size. And the class size here is 166.5 minus 161.5, and that gives you an interval class size of 5. So if you worked out this, you'll get 161.5 plus 3 all over 6 times 5. So these are half of 5. And that will give you 161.5 plus a half of 5. That gives you 2.5. And this, therefore, will give you, that will be 62 plus 2, 164 as the mod. So the most occurring height is 164. And true, you can check through. We have several. 164, 164, 164, 164, 164. It is the most occurring. From inspection of the raw data, 164 is the most common. By computation, 164 is the most common. So our median, our model value is 154. Most students, this is now the interpretation. Most students have a height of 164 centimeters. That is what we talk about. Now, finally, we look at the median. The median was an estimate that this was L plus N over 2 minus CF all over F multiplied by I. And we did interpret L as the lower class boundary of the median class. What is this median class? This is the class that occupies the halfway. the n over 2, remember, it occupies the n over 2 item. That's where the median class is. So we get its lower class boundary. N is the total number of observations. Then CF was the cumulative frequency up to the class preceding, just before the median class. And our F, we interpreted F to be the frequency of that median class. I is standard, this is the class I. So from this, let us identify the median class. How do we identify that? We must generate the cumulative frequencies. How do we generate the cumulative frequency? We ask ourselves, up to how many students have a height of less than 142? The answer would be 0. How many students have a height of up to 146? Then we have 2. These 2. How many students have up to a height of 151? So it will be 2 plus 5 to give us 7. How many students have up to a height of 156? It's 2 plus 5 plus 6. And that therefore gives us 13. What we are doing, we are accumulating. And that's why when we talk of cumulative frequency, we are accumulating the frequencies as we go by. So it is a matter of 2, then 2 plus 5, 7, 7 plus 6, 13, 13 plus 4, that gives you 17, 17 plus 7, that gives you 24, 24 plus 4, that gives you 28, and then 28 plus 4, that gives you 32. Notice that the value we get here should be equal to the total frequency because we are accumulating all of them. So this value and this value should be the same. Now, what are we left with? We are left with identifying the n over 2 item. Our n here is 32. Divide by 2, this gives you 16. So where is this item 16? We check through the cumulative frequency. This up to here we have 13. Up to here we have 17. So number 16 must be in this. And therefore, working backward, our median class will be the class corresponding to that. That which I have circled. So number 16, because up to here there are 13, so number 16 should be among these. Because the total here would be 17. Which means that our median class, therefore, is 157 to 161. So from this, therefore, we can get our lower class boundary. Consequently, therefore, our median shall be the lower class boundary of this. Look at the distribution. This will extend from 156.5, 161.5. So our lower class boundary is 156.5 plus our n over 2 gave us 16 minus cumulative frequency up to the class preceding. This is where we are, 17. The cumulative of the preceding, that preceding is what comes before. So what comes before is 13 divided by F is the frequency of the median class. This is our median class, 157 to 161. What is the frequency of that? The frequency of that is 4. And the class size, which we know how to get, 161.5 minus 156.5, that gives us 5. Which, when you substitute, you have 156.5 plus, this is 3 all over 4 times 5. So evaluate this, gives you 156.5 plus 3 over 4, that's 15, all over 4, and that will give you 3 points. 3, that is 12, the remainder is 30, 7, then 5. So this will give you That will be 5. 7 plus 5 is 2. 3 plus this. 3 plus 6 is 9. 5, 1. So we get 159.25. And this is the height of the student who occupies the 16th position. The central is 159.25. So that is how we can evaluate the mean, mode, and then the median. In summary, therefore, we find that the mean is 159.78. The mode is 164. The median is 159.25. These are the measures of central tendency. These are the measures that describe the given set of data that we have. The measure that describe this observation. Now, what conclusions can we draw? We can make a conclusion about the nature of this distribution by comparing these three values. Now, if you compare these three values, if you compare these three values, there are two options that you may get the mean being equal to the mode, which equals to the median. The three can be equal. When these three are equal, then we say that that distribution is normally distributed, and therefore it is referred to as a normal distribution. When these three are approximately the same, then that set of data is normally distributed. It is a normal distribution. But when now the mean is not equal to the mode and is not equal to the median, then that set of data is referred to as a skewed distribution. Skewed meaning it is tilted to one side. So it can be tilted to the left or it can be tilted to the right. When it is tilted to the right, we say it's positively skewed. When it is tilted to the left, we say it's negatively skewed. So the nature of skewness, for those of you who are taking BCom, for those of you who are taking SMA, for those of you who are taking criminology, you will do that now in your social statistics. Those statistics courses that you will now take there, you will now look into the details of skewness. Positive skew, normal skew. Characteristics of the normal distribution, which is bell-shaped, you will now delve into that. But this one, we are giving you the basics that are required for those other courses that will come. So this concept of statistics can be used at a time in your future courses, especially for some of those programs that I have just said, including education, because you will be analyzing student performance and you want to find out how is this performance. The performance is compared of this. You will be looking at the mean. So you know that how was this exam? You'll do that in your third year in a course referred to as measurement and evaluation for teachers. So the concept of statistics is a concept that cuts across and a concept that you will use in your future programs. So this is how we look at it. This is how we compute the mean, this is how we compute the median, and this is how we compute the mode. So as we do this, we are mainly looking at the end result, a comparison of the two. Is it normally distributed or is it a skewed distribution? This is how it is done. And this is what is to be noted. What is to be noted is, once we have generated the intervals and the frequency, we should generate the midpoint for a grouped distribution. This midpoint gives us x, the average of the two. Please, this is the average of the two. Limit 142 plus 146 divided by 2 gives you 144. And that's what it is. If you are careful, then you realize that this is a regular distribution. And therefore, the differences between the midpoint is just the class size. When you work out, then you realize that they are differing by 555, which was, in essence, our class size from the classes, the intervals. That is what we have. Now, before we perhaps look at something else or an exercise, let us make a comment. Let us make a comment about measures of position. We have said that the median is a measure of position. Now, is it the only measure of position? The answer is definitely no. There are other measures of position which we can use to describe a given set of data. These other measures of position are also classified under the measures of temperature. And there are three in the number. Number one is what we refer to as the quartile. By the word quarter. Quarter means 4. So quartiles divide a given set of data into 4 equal parts. They divide a given set of data into 4 equal parts. So if we can borrow from the concept of the number line, that if this is my line, the median will divide it into 2 equal parts. So I'll have this as my median. 2 equal parts. Now, quarter is divided into 4 equal parts. So I'll have this, that. So these are 1, 2, 3, 4 parts. This is for quarter 1, quarter 2, quarter 3. So we are dividing it into 4 equal parts. But we have how many quarters? 1, 2, 3. So meaning that we have 4 quarters, but we have 4 divisions, but there are basically 3. What does this therefore mean? That because it's a measure of position, we can look at either quarter 1, quarter 2, or quarter 3. So if I'm looking at the kth quartile, which can either be 1, 2, 3, then this is also a measure of position, and I can look at it from the basis of the measure of position of the median. So this can be estimated as L plus Kn over, because now it does not divide the data into 2, it divides the data into 4, minus the Cf all over F multiplied by I, where now K will take on values 1, 2, and 3. 1, 2, and 3. Please follow keenly, because the kth quartile, K can take on quarter 1, quarter 2, and quarter 3. There are 4 parts, but there are 3 quarters, as explained from the number line. So the CF and the F plus L are defined the same way we have defined them in our median. So we can get Q1, we can get Q2, we can get Q3 when K takes on 1, 2, 3. The second other measure of position is what we refer to as the decile. Deci means 10. And therefore, when you talk of the decile, this divides a given set of data into 10 equal parts. 10 equal parts. And therefore, the kth decile will be L plus Kn all over. Because we are looking at decile, and deci means 10, this will be divided by 10. Minus Cf all over F multiplied by I. For K will take on values 1, 2, 3 up to 9. The same argument, why we are talking of 10 parts, but K takes on value up to 9, is derived from what we have explained under the quarter. Quarter means 4. But if you borrow from the number line, we cannot have 1 and 3. And that is what gives us the 4 parts. So similarly, for the decile, 10 equal parts, it means we can compute up to the 9. Because the 10th one will be talking of the whole. If K takes on 10, then this is just N, the whole total. Another final measure of position is what we refer to as the percentile. From percent means 100. So percentile means 100 equal parts. 100 equal parts. Meaning that the kth percentile, the pk, this will therefore be L plus kn over 100 minus cf all over f, and everything multiplied by I. For k takes on values 1, 2, 3, and this goes on up to 99. This is the same explanation as seen from the quartile. From quartiles to percentile, and then from quartiles, deciles, and percentiles. So we are using the same formula, but what is only changing is this part. That's the only part that is changing, because this is drawn from the median. All these are measures of position. Median, we said L plus N over 2 minus CF all over F, this multiplied by I. That this is the part that is changing. When the data is divided into 2 equal parts, then that's the median. When the data is divided into 4 equal parts, then that's the quartile, Kn over 4. When the data is divided into 10 equal parts, then that's the decile. And when the data is divided into 100 equal parts, then that is the percentile. So this is the part that changes in all these, and all these are measures of position. Let us look at an example on each one of them before see. I want to look at the quartile. Any. If you allowed, I look at the first quartile. I want to look at Q1, the first quartile. With the Q1, K takes on 1, so this would be equal to N plus 1N, that remains with N over 4, minus CF all over F multiplied by R. Now my essence is, how do I now get this? Because it's 1N over 4. So my N over 4 would be equal to 32 all over 4, and that is 8. So my position is the 8th item. I go back to my table. The cumulative frequency, where is number 8? Up to here of 7, up to here of 13. And therefore, number 8 will be in this 13. So if that's where number 8 falls, what I'm highlighting in black, this is now where my number 8 will fall. With now a class in the class of 152 to 156. That's where it falls. And therefore, if I substitute in this, the lower class boundary, which we now know how to get, of this interval shall be the average of 152 and 151. That gives you 151.5 plus n over 4 gives you 8. Already we have it. Minus CF, cumulative frequency up to the class preceding where it falls. We are here. What precedes is 7 divided by F is the frequency of that interval, 152 to 156. This is where we are, and therefore the frequency is 6 times 5. And this therefore will give you 151.5 plus 1 all over 6 times 5. So 5 over 6, that will give you 0.8, that's 48. 3, that is 18. 3 recurring. So this would give us 151 plus 0.5 plus 0.833, and that will be equal to, that will be 3. 8 plus 5, that's 12, carry 1, 2, 5, 1. So it will give us 152.23 centimeters. What does this mean? The eighth student has 152.233 centimeters. That is what that means. When the Q3 now is calculated, we shall have Q3. So we shall have 3n over 4. 3n over 4 will give you 3 by 32 all over 4, and that will give you 24. So you look at where is number 24. If we are finding the Q3. So where is number 24? Number 24 is here with a class of 162 to 166. And therefore our L can be computed in that order. With the time, you will notice that the median will be equal to the Q2. And you can see it even from here. This divides the set of data into 2. When you are talking of the Q2, our K is 2. So 2n over 4, this will give you n over 2. So this one here is 1, this one here is 2. So this one stands that the median is normally the Q2 for that matter. We can do one decile. We can do one decile. Unfortunately, we are not able to allow you to talk, so you may not choose which one. I can do a unique one. We can do
Hello, sir.
6, for example. We want 6. Side 6. So this will give us n plus 6 n over 10 minus cf all over f multiplied by r, where 6n over 10 will be equal to 6 by 32 all over 10. And that will give us 19.2. If I'm not wrong, that will be 12, 18, 19. So we want 19.2 item.
You are wrong.
19.2 item. You come to your cumulative frequency. Up to here, you have 17. So number 19 must be in this.
Wrong.
Number 19 should be in this. So it falls in the class of 162 to 167. 162 to 167, because we are looking at number 19.2. Up to here we have 17. Up to here we have 24. So number 19 must be among these, which corresponds to 162 to 166 with a frequency of 7. Which therefore, when we substitute, the lower class boundary is 161.5 plus 6n over 10. That gives us 19.2 minus 19.2. They are here. TF is what precedes. What comes before is 17 divided by f is the frequency of that interval, 7. And this multiplied by I. So this will give you 161.5 plus, this is 2.7 all over 7 times 5. So that is 35, 10, 13 divided by 7. This is 1. The remainder is 5. Into 5. 8, 4. 1.841. So this will give you 161.5 plus approximately 1.81. And that will be equal to 1, 13, and this 2, 3, 6, 1. Around 163.31. That is what it is.
Is it 2.7 or
The same formula, the same approach can be used now to get the percentile. We may want to find out maybe the 80th percentile. When we talk of P80, P80 with substitute here will give us L plus 8N over 100.
You are too fast.
All over F. I. So we want to keep the N in the time 32 all over 100. This will give you 3.2 by 8, that's 16, 24, 25. This will give us 25.6. The class where 25.6 falls are here. We look through and identify where there's 25.6. Up to here is 17. Up to here is 24. Up to here is 28. So 25.6 has to fall among these 28, which corresponds to 167 to 171. So the class is 167 to 11. And therefore, P8 is equal to the lower class boundary here is 166.5 plus 8n over 100, that's 25.6 minus what comes before 24 divided by the frequency of that interval. The frequency of that interval is 4 multiplied by plus 5. So this will give you 166.5 plus 1 point all over 4 by 5. That is 0.2, 0.4 by 5, that's 2. This will give you 166.5 plus 2, and that will be equal to 168. 168.5. So 80%, because it's percentile, 80% of the student are 168.5 centimeters. The interpretation is key. 80%, because we are talking of the 80th percentile, are 168.5%. That is where, that is what measures of central tendency are all about, and all other related measures of. So let us get to see the other examples that you had, what answers you could find. We can now shift to that one.
Excuse me, left.
Kombinio kama gari.
Unatupeleka mbio bwana.
Kwani hii hamuoni kitu imerekodiwa?
Hamuna uwezo, piga kelele. Akifunga unajua. Hiyo ni yenu, mwalimu, tumia lugha nyepesi. That's the simplest language I'm using.
Wewe mwalimu uko sawa, endelea.
Naomba utumie kibukusu.
Hiyo ni kama matusi. Kuzi ni onda na language of instruction.
Mimi hata tushikanishi.
Mwalimu wako sawa, tushikanishi.
Mbona sasa wajika class
Ameenda. Unafikiria ni rahisi kuacha hivyo? Tutumie lugha nyepesi.
Yes, we can listen to order. Listen to what others are raising. I think somebody with the techno BF7, your hand is up.
I wanted you to repeat, to go through again.
Bwana.
Finish your 7.
Somebody wanted that we repeat?
No.
Yes.
Percentile.
Repeated today. I've done even 3 examples.
Yes.
Others are saying that I'm clear. These are things we done last week. I was clearing the misunderstanding that was there.
Consult me.
And if I realize that there are some people who are only taking it for a joke, then it will be unfortunate for them. Now let us see what happens. I'm sharing the screen as we proceed.
Hey.
This is what we are saying, that we have related measures of position, and this is what we have done, or this should be K.
Matendo wachache.
So now with this in mind, therefore, we can, and we have already looked at an example because there are 3 measures, little measures of position, the quartiles, deciles, and percentiles. That is what we have looked at, and we have done an example. Look at this example. Look at this example. It is visible, or I can magnify it. So look at those values, and we are saying that these are scores of students in a Swahili examination. Please look at them. And we want to make
A group frequency distribution with the intervals 25 to 29 as the first class. Then we determine the mean, mode, and median mark. Then you comment. Now, this is a standard question. When you are asked to comment in such a case, then the comment must reflect on the nature of the distribution. How is the mean, mode, and median? Are they equal or almost equal? Are they approximately equal? If they are, then we conclude and comment that that is a normal distribution, that the exam was normally repeated. But if they are not, then the comment should be that the exam was skewed. That is how we interpret. Because we say statistics will deal with methods of collecting, organizing, analyzing, interpreting, presenting, and we must interpret it correctly so that we take decisions. That is what that exercise is. So you can look at that and see what happens. There are more examples, more exercises in your LMS. Perhaps to find out, do we still have challenges in logging in to LMS?
No.
Do we still have people who have challenges in logging into LMS?
No.
So all of you are now logged in and you can access the notes.
No. Yes. No.
No.
Feedback.
The problem is
So some of you say no, others yes. It confuses now. I don't know what.
No,
What you
they don't
mean.
allow us.
You don't have?
What is LMS?
Ladies that you have not registered.
Yes, first years mkiwa wasumbufu. Unajua mtaumia.
What is LMS?
Can we have order so that I get to understand if there are any challenges that you are facing? It should not just be a matter of saying no or yes for the sake of saying. Where is the challenge?
Yeah, 2023.
Yes, doc. I've raised the hand one.
Sijakuona from my side.
I've raised the hand.
Proceed and talk.
I'm saying that the problem concerned that we have those that who have not able to log in because of
our daughter ameweka microphone on. You are in first year and you are already babysitting. Now give you for the utakuwa nyanya. Come on you. You switch off your microphone. Nani ana mtoto?
Yes, doctor. Raise the hand.
Wewe ukiwa kwa nyumba, ensure that you mute. I'm not going to take it kindly mkutulilisha watoto. Tumewacha watoto kwa nyumba. Wewe mwanafunzi ama wewe ni mama? At first year and you already breastfeeding. Na ukifika kwa
Nashangaa sana.
When we are dealing with serious matters of academic, unatuwekea sauti tusikie mtoto akilia. Tunyonyeshe mtoto. Mbavu kabisa.
I wonder.
And if I not you, wewe sumbua tu kwa darasa yangu. We will see if you go to second year. Yes, somebody was raising an issue.
Yes, I was
about registering and accessing. Where is the challenge?
I was saying this. Yes, hello.
Enrollment key, Geoffrey Majune, you are given enrollment key. KUC1250 Jan 2024.
25 to 29.
That is the enrollment key.
29 is zero.
Hello.
Yes.
That was not most of the issue. Not the main problem. The main problem mostly is concerning. We have those people who have not join this class because of fee problem, which is scholarships. So the one that's the main problem.
Yeah, so it's because of having not paid the fees. That's why you cannot access.
No,
but
they
it's
have
not
paid
because
fees.
of any technical problems from the side of the course.
I was saying that they have paid the fees, but the problem concerned their scholarship are not reflected to school accounts, so they will not be able.
Yeah, so what we do is this. Okay?
Yes.
Those notes are downloadable. You can download them. The essence is for you to access. And once you have accessed, you can download them and do them, read them at your own time.
LMS. Yes.
Yes.
You cannot download if you have not registered the unit.
Yes, you
cannot download
without
if
registration.
you have not registered the units.
Even the card online cannot be used.
Yeah, and the card is coming in the last week of this month.
Card cannot be done online if you have not registered, because there's no who will take the online.
We have online portal and student portal.
Where my friend,
can you listen?
You cannot do a card online without registering the units, my friend. I have been in the you cannot do it because you must enroll first.
Download notes afterward.
Engineer Rabs, can you mute?
This I think you are confusing e-learning portal and student portal. Restrictions lies on the student portal.
Exactly.
E-learning portal is very open, having a balance or not having a balance, you can access the content. Please don't confuse e-learning portal and student portal.
Exactly.
Mmesikia hiyo?
Yes.
So don't confuse.
And I have not cleared fees.
And those, we are saying this is the information. What is accessing the learning materials has nothing to do with the fee balance.
Yes.
You can access even with a balance.
So.
Yes. So that should not be an excuse. And Brian, kindly mute. Now, mute what taken BF must mute. If you don't, I'll mute you by force.
Sawa mkuu, chapa kazi.
Sawa. Okay. Acha tuendelee tuone tuko wapi. Now, I had given you this work on your screen.
Yeah, last.
Did you do it? What was the value of your mod? I gave you this.
Hey,
ulienda ukafanya.
Okay, nakaa nyinyi mnafanya tu mchezo. Now let us proceed and look at the final part. Measures of variation in terms of analysis. Let us look at this. Measures of variation. We have been looking at measures of central tendency. So when we talk of variation, variation means a change arising and a change that gives us a difference. So when we talk of measures of variation in statistics, we are focusing on those measures that describe how a given observation differs from a central value. And this central value is normally the mean. Why is it that the mean is the most important central value measure of central tendency? It's because it is more responsive to individual observation. When you change a single value, the mean is affected, unlike the mode and the median. When you just change a given set of data by a single value, say if instead of 10, you put there 12. What changes or what is affected most is the mean. And therefore, the mean becomes the most important measure of central tendency. But as we look at variation, we must also understand what are the best measures. What characteristics should a measure of variation possess? That the following properties are important. That a good measure of variation is simple to understand because it has to explain to us in simple terms where the differences occur from the mean. Should be easy to compute and should be rigidly defined. To this end, therefore, each and every observation of the distribution should be affected by the measure. Now, as we look at this, we want to go deeper and focus on specific measures that help us to understand. To this end, therefore, there are certain methods we can use to analyze variation. There are certain measures that the simplest is what we do refer to as the range. The range is just the difference between the largest and the smallest observation. Like in the example we have been looking at, 173 and 161. That difference, the highest and the least observation, that gives us the range. Now we have what we call the quartile range, interquartile range. We have looked at measures of position. How do we compute the quartile 1, quartile 2, and quartile 3? In the practice, you realize that quartile 2 is actually the median. It's equal to the median. In the practice, you realize that percentile 50 is equal to decile 5 is equal to quartile 2, and that is what actually gives us the median. That is the standard. They are the same. Now, the difference between the third quartile and the first quartile, that's what gives us the interquartile range. And the average or the half of that interquartile range is what describes what is defined as the semi-interquartile range, or otherwise the quartile deviation, because we are looking at it from the measures of position. But that notwithstanding, that the differences in terms of what the observations are from the measure of central tendency, which is the mean, that is what gives us the deviation. That the deviation should always be positive or negative. And mostly if you sum the deviation, they'll give you 0. Now, how do we go about? Because working with a 0, the properties of 0, n number divided by 0, and 0 divided by n number, we know this gives us 0 or is undefined. In most cases, it's indeterminate forms. So that the deviation should always be positive or negative. The variation? And mostly if you sum the deviation, it will give you 0. By way of squaring those deviations. We go about. If we square those deviations and get the mean of the squared deviations, then what we get is what we call the variance. And 0 divided by n number. We know this. That variance gives us is 0 or is an gives as the basis, as a measure. In most cases, it's indeterminate forms. So that the deviation should always be positive or negative deviation. Mean of the square deviation will give you that by way of squaring. Now, how do we get back? We understand the variation. If we square the deviation 0 and properties of 0 the square deviation. That's n divided by 0. What now gives us what we call the variance. And 0 divided by n number. It is the positive square root of variance. Where variance gives us is the square, the mean of the basis as a measure. In most cases, it's indeterminate forms. So that the deviation will always be one negative deviation. Mean of the square deviation will give you that by way of range. Where now, how we can do them by way of understand the deviation 0 and properties of 0 square deviation. That n divided by 0. Where when we get the positive square, it gives us the standard deviation. And the positive square in terms of where variance gives us 0, the mean as a measure. In most cases, it's indeterminate form. And mean of the square where now how we can them by way of understand that n divided by 0. Well, when we get what we call I think that's better now. Yeah. So if we want to analyze the spread, then we analyze variations. How do we interpret now? Because the key thing is to interpret the standard deviation. Standard deviation tells us more about the similarity, the identicalness of the observation. This is what is described as the homogeneity. That the smaller the value of the standard deviation, the more identical, the more homogeneous the observations are. What does this mean? They are closely related. If we are looking at the cells of a given enterprise, then a small value of the standard deviation will indicate that if it's daily sales for a period of 1 week, will indicate that the cells are more close and related. Consequently, the more the higher the standard deviation, the more different the cells will be. The more heterogeneous, therefore, they will be. It will not be identical. Meaning, you can sell 1,000 today, tomorrow 5,000, the following day 500, and like that. But if they are identical, then it means you are selling, if it's 1,000, tomorrow 1,200, the following day 1,100, they are more close. And this, therefore, is good in terms of interpreting how similar the observations are. Are they within the same margins? And we can confirm this by computing what we call coefficient of variation. Coefficient of variation is just the standard deviation divided by the mean times 100, which gives us the percentage proportion of the variation that can be explained as a result of the differences in the observations. That is what we are talking about. So if anything, then we are able to, and we are truly able to interpret that correctly. So we wish to look at how do we go ahead to find out this animal that we are saying is analysis of variation. That if it is ungrouped data and if it is a grouped data, then that will conclude our analysis. Let us look at some examples so that we could perhaps see to it that we are able to compute this. Let us see, before we come back now, to conclude. Are we there? Now, we have had this example already. We did see the mean, mode, and median. If you recall, then we had, for the mean, we had fx as 288, 745, 924, 636, 1148, 676, 696. The total was 5113. We found the mean to be equal to 5113 divided by 32, and this is what we approximated to 159.78. 159.78. Now, we wish to go step by step and understand what we are referring to as the variation. That how do this set of observation differ from a central value, which is normally the mean? That for us to understand this, then there's need for us to get the deviation. How do we get the deviation? The deviation is just the mean, the observation minus the mean. This deviation
is what we can denote as D. It will give us positive or negative values. But because it's positive and negative, we need to get the squares so that we normalize that. Remember I said, if you have 0 over a number, say 100, or 100 divided by 0, this is indeterminate form, undefined form. So we square that. But because it's occurring with frequencies, then we shall get FD squared, where our D is x minus x bar. So this is the most important column. The most important column that you can complete this at your free time and see if you get the following. That for this, I've already worked out this example. This is 498.02, 581.04, 200.45, 2.43, 124.66, 340.3.03, then finally 808.83, and that total gives us 2555.46. Please, you will confirm these figures. Get the difference. 144 minus 159. Complete. Square that. Complete. Then multiply by 2. Confirm that it gives you that. So that at the end of the day, we are getting the value of the variance. How are they varying from the given set of observations? This is what is defined as sum of FD squared, where D is equals to x minus x bar. So it can be written in either form. We have several other formulas that we can use. This divided by the sum of F. This is the simplest for you to remember. D for deviation. So this will give us 2555.46 divided by N, which is 32. And if you do that, then you will get what we refer to as the variance. Now, how do we get the standard deviation? The standard deviation, because we had squared the deviations, now we work backward. S squared, that means we shall get S. To get S, which is now the standard deviation, it means we get the positive square root of the variance, which consequently gives us the positive square root of 255.46 divided by 32. I hope you have calculators. This will approximate to 82.46. 82.46. Now, do we say that these are large or a small value? A standard deviation of less than 5 is assumed to be small. A standard deviation of 82 kind of, this is large. And therefore, there exist high variations within this set of data that we looked at earlier. But we can go ahead and now see what proportion is it explained. So for us to see that, we compute the coefficient of variation, which is normally the standard deviation over the mean times 100. So this, in essence, will be 82.46 divided by our mean was 159 0.78 times 100. And that will give you a value. So how shall we interpret this? This is the percentage proportion that can be explained from the internal variations of those observations. The percentage proportion is given by the coefficient of variation. Now, allow me explain this in a different way. That many times we may have a set of data. A set of data that has two sets. I may have the male, let me be gender sensitive, the male and the female. This can be in terms of weight, in terms of their money, in terms of their height, in terms of any characteristic of interest, any variable for that matter. So I may want to compare male then female. When you do this comparison, even if in terms of performance, you may find that the male is 24.5. Then the mean for the female is also 24.5. Does this therefore mean that the male and female are equal because they have the same average? The answer is no. If two sets of observation have the same mean, it doesn't always follow that they are the same. What we need to do is we go further and estimate the standard deviation for the male and then the standard deviation for the female. Please get this clearly. The standard deviation for the male, the standard deviation for the female. Now, despite them having the same average, the same mean, their standard deviation, the variability, the difference between the observations and their mean will create a deviation. That deviation is what we are referring to as the standard deviation may not be the same. Now, to get the percentage proportion of what can be explained for male and female, then you check for the coefficient of variation for male, then the coefficient of variation for female. Even if they have the same mean, they may have almost the same standard deviation. The coefficient of variation, what is explained, will never, ever be the same. That's why in the analysis of variance, it is good to get the standard deviation and go further to get the percentage proportion of what is explained in terms of the coefficient of variation. So two sets of data, say male and female, can be the same, but their standard deviation may also be almost the same. The difference lies in what percentage proportion of that variation can be explained, and this is expressed in terms of the coefficient of variation. And the coefficient of variation, ladies and gentlemen, is the standard deviation divided by the mean times 100, and that gives you what it is. So the smaller the coefficient of variation, the better, the more identical the observations are, just as we did see in terms of interpreting the standard deviation. That is how we are able to look at this. That variability is the difference between the observation and the mean. This would be positive or negative. So to avoid the negatives, we square those deviations. But because they are occurring with frequencies, we get the product. That sum total product divided by the number of observations gives you the variance, S squared. Because we had squared, that's the variance. The mean of the squared variations or deviations, that's what the variance is. Now, because you had squared, the positive square root of variance is what gives you the standard deviation. Two sets of data can have the same mean, almost identical standard deviation, but the coefficient of variation gives the difference. So we can analyze up to and including the coefficient of variation to get the exact and defined percentage proportion of what explains that variation. I just used male, female. This can be businesses. This can be any other variable that we are talking about. We can compare businesses. We want to see how is business A doing and how is business B performing. We can as well compare universities. Kibabi versus Masinde Muliro. We might do the same thing, the same program, but at some point, there exist differences which can be obtained by the coefficient of variation. That is how we go about it. Let us check if we have a simpler example again that you may attempt and push it onto the wall. Let's get to the machine.
Right. I don't write, I just share with them. Your methods of studying variation. Yeah. Yametaka hiyo. Are we there? Enrollment kini gani? Hata mnasumbua. These are the jokers. You see what they're doing? They're now talking about Sarashi. Enrollment kini gani? Unaona penye umeenda? Yeah, sir. Okay, let us proceed because I see people are now beginning to be salacious here. Look at that set of data. Can we find the standard deviation? Let us find the standard deviation of that set of data. Then we proceed. We check the answers. I'm going to do something else. We are just now working examples. This is a group set of data. Find the standard deviation from the weekly wages of 10 workers working in a factory as given. Wewe endelea build anaendelea kutoelewa na mnaongea mambo ya salazi hapa. Kila mimi niko na wakati ya quest. Giving them two examples. Wafanye leta majibu. These are grouped. Iko nyingine hapa chini. Please, I'm waiting for answers on the chat box. Somebody is asking for the formula for ungrouped. It is sum of the squared deviations divided by the number of observations. Songa mbele. Got a 7.89. Mike Nuts, I see 7.89. Let's see what others will be getting. 7.89. I like giving answers to 2 decimal places. Rebecca, that's fine. Duncan, my namesake, that's fine. Sharon, it's 7.7. No, check. Nicodemus, I can see it. Kevin Smiu. Kuna wale wako serious, angalia vile majibu inaingia. Kuna wale wako serious. Okay. There are the results. The mean is The mean is 1322 and the standard deviation is 7.89. Good for those who got it. Example 2. I had given you this. The age and death of patients in a certain hospital was recorded as follows. You have this example already with you. So there we are. The age and death of patients in a certain hospital was recorded as follows. We have this, we did it the other time. Let us find the mean, the standard deviation, the variance, and what have you. Let us find the mean. We can find the mode, the median. Find the mean, mode, and median, then comment. Then proceed to find the standard deviation.
Next week, if one may organize what to look at the thing, maybe after one. I would have gone after 1 hour.
Mwaka unapanga next week. Pande itakuwa the 3.59 to the 3.6, the 3.59, and the 3.59. Then deviation 73. Aye. Equal you sana. Please check. You write there the mean, mode, median, or the standard deviation for the answers you are giving. Please. The mean cannot be 5. Median is 4. Median cannot be 4. Standard deviation is 73, no. Mean is 269. It cannot go beyond the edge. Mean is 21. No. The variance, you are about there. Yes. 1.29. Mean cannot be outside. It should be between 30 and 69. Mod 50, 1.9. Look at that set of data of mine. Look at that. The mean is 51.29. The variance is 73.30. Look at those results. Example 2 or 3. Look at that table on the number of children attending a clinic. Display the whole table kindly. Daniel, what are you asking? I've displayed the table. The table is there. There is the table. Daniel, there is the table. You're asking how do we get the Nini, and I had explained that. And Akea, that's good work. It's a normal distribution. Peter Zalazia, wewe hapana bwana. People displayed halfway. Wana nataka display table na unakani. To delete. I have no option of deleting from here. Oh, imesonga chini. Ndio walitaka. They will display the whole table. There it is. It's a bit from it. Variance, please. Please, the table is there. You can use it for any other computations. We look at the next example. Look at that example. Work on that example 3. Yes, director. Please work out example 3. Mean on example 3, 39.46, mean 39.46. Proceed. See the mean 39.46, others are getting. Summation gives 50, while these others gives. This and this is 20. 20 plus 30 is 50, yeah. It should be 50. It's 30, 45, 50. They are 50, not 60. I take note of that. Proceed to get the variance and standard deviation. Mean 39. 39, 40, 45. So Sandra Kemunto, what comment can you give to the nature of the distribution? Sandra, give the comment. Alan Maruka, keep it up. Is that normal distribution? Kevin Simiyu, is that normal? Is the mean equal to the median and equal to the mode? Definitely, I doubt. Cynthia Mochi, is that the standard deviation or that is the variance? Skewed distribution. Kuna wale wanapata. Wengine hapana. Okay, look at the results. Look at the results. Look at those results and compare with yours. Please check. Eric Bosire, unmute and speak. My results are not correct. Midpoint zangu. Okay. I can repeat that and report back in the next class if I've erred. But you can have the following exercise as I look at this example. Look at the following exercises. That's exercise number 1. Exercise number 2. Look at exercise number 2. Most of you have phones and you can easily screenshot. You want exercise 1? There it is. There is exercise 1. How can you repeat column of D? How to substitute in that column? Column of D. That column of the D is the deviation, the difference between the observation and the mean. X minus X bar. Geoffrey Majuna, that column is the observation or the midpoint minus the mean. So you first calculate the mean for you to get that column. Now let us look at the last part of our presentation, and we wish to scan through this because this might be easier for you. That once we have collected, organized, analyzed, now we can represent data. Data representation utilizes the use of graphs, and graphs depict the relationship between the variables. And this relationship comes in form of a line or a curve. It can also come in terms of bars. But what is it that we need to know about graph constructions? Because data representation is only about graphs. That we need to have a clear and comprehensive title on it. And always the dependent variable is on the x-axis, while the dependent variable is on the y-axis. That the scales on the x and y-axis need to be uniform, and we need to be very clear not to overcrowd. That if we are using lines, let them be clear and distinct. And if we are doing in terms of that application, then we must also give the source of our data. These are the key principles that guide data representation, especially on use of graphs. There are various types of graphs. We have bar graphs, line graphs, histograms, pie charts, and most importantly, the Lorentz curve. The Lorentz curve gives us a measure of variations that we have looked at. That a frequency distribution can always be presented graphically in any of the following ways. We can present it through a histogram, a polygon, a curve, or a cumulative curve, which normally reflects what we call the ogive. Now, because some of you are becoming too lazy, you don't want to go to the portal, to the LMS, to get access to materials. So I'll not discuss these types of graphs and how they are constructed. Go to the LMS, read the notes that are presented there regarding these types of graphs, the bar graphs, line graphs, histograms, pie charts, and the Lorentz curves. All of them are there. Frequency polygons, frequency curves, and ogives are presented in the lecture notes. So I give you that as a reading assignment. So to this end, therefore, we conclude our discussion. It doesn't matter whether they are for 2019 or whatever, some. Those are the course materials provided. Go read them. It's the same course. Go read them. So whether they are downloadable or not, you can access them anywhere, even from your house. So that is what it means. The materials are there, and look at them. That is what I'm saying. Okay? So we come to an end of the of our first concept, our first part. This is on statistics. We shall proceed to look at other parts in the course of next week. Unless somebody has a question, we wish to adjourn. If you have any question, you raise your hand. If you have any question in the chat box, please, I've given you work. Can you discuss the 2 questions and even the other exercises that I have given you? There are exercises even in and examples in the materials uploaded for your reading. How can we get notes in the PDF? Please stop asking the same questions. The notes are on the LMS. You access it. It's not my business to know how you access that. We can't continue 15 minutes. We are through and we want to start a new topic, which you cannot start today. Where is your office found? ABB 214. ABB 214. I hope we use groups that is available. That is for your own arrangement. See you next week. Thank you so much. EDS 0681. How to find standard deviation. You can come for consultations. You are insisting I repeat column D. I've repeated that twice. Will the card be online or physical? We'll cross the bridge when we get there. John Bado, I'm going to deal with you people. Will you take me through consultation? Welcome. I'm in the office. It's your own interest to consult. Mary Wamara, you want a physical cut? Yes, that's your wish. But your wish may not be the plan. Punguza nini? Can we be given method marks? I don't know Bryson Amunga. Where is the office? I don't know where the office is, but it's ABB 214. Thank you so much. I think we can adjourn from there. Have a blessed day and enjoy the weekend ahead. Thank you so much. Unmute us. Okay, you are being unmuted.
Yes.
Nasemaje kiongozi? Wewe umeandika online class wewe bana, utakupea yako peke yako.
Punguza kielele hapa.
Unaandika physical class wewe wampea peke yako.
Punguza midomo.
Umbwa wewe.
Nani umbwa?
Wewe.
Mimi umbwa.
Wewe. Wewe ni umbwa.
Kwenu mko na umbwa hata paka mko nayo hata kuku hata panya kwa kwenu.
Mende.
Ingine mko na sauti mbaya mbaya hapa sinagwara.
Mwenyewe inagwara.
Hebu sikia yangu ni tamu hapa.
Kedele.
Wengine pesa zenu zinaweza pamua nyumba.
Alafu baada kuelewa kitu watu kwetu physical.
Afadhali wewe unaelewa kitu physical.
Nani naongea class iko physical bana. Chapa.
Wewe kati kwa physical.
Skodi wewe.
Class
na physical kama jamaa.
yako.
Hawezi kufanya math online bana. Kati inakuwa physical.
Na float msee.
Utafanya bwana. Walimu weka kazi kwa physical. Lao majamaa watafanya bwana.
Atu update aje sasa?
Basi kwa physical.
Ita nini itatoka? Tunajaribu sasa.
Watu wakifika 50 hiyo inatoka huko zake. Watu wakifika 50
physical. That is physical. Nasikia?
Jamaa ame insist cuts ni physical.
You idiot. That is physical. Nasikia?
Eric.
Yeah. I'm saying that this card will be physical.
Chacha.
Students.
Eric.
Students. Did you hear what I said?
Yeah.
I said this card will be physical.
Nenda uko kwani wewe ndio lecturer.
This card will be physical, and I don't know why you people are arguing. I've already confirmed with the student.
I just say
Are we together?